Perhaps the best place to see the impact of the sun's heat is an area in the Atlantic just north of the equator and west of Africa, the coastal waters of the Cape Verde Islands. Here, the sea provides a living. The local fishermen keep a careful eye on the weather. They know that storms can bring a good catch. Turbulent weather stirs up nutrients from the deep, attracting great shoals of fish. It's the hottest time of the year, and the sun beats down relentlessly. By late afternoon, the huge inflow of heat energy has led to the buildup of large cloud formations. Sometimes these formations develop into massive storms. It's a process that satellites are revealing in fine detail. Circling above the fishermen is a NASA satellite called Aqua, Latin for water. It orbits the poles. One of its key tasks is to monitor the complex interaction between sunlight and water.
Aqua satellite is one of NASA's flagship satellites. Its primary function is to study the hydrologic cycle on Earth. Vapor in the atmosphere, liquid ocean, the temperature of that ocean, and the ice.
One of Aqua's instruments looks down at the sea around Cape Verde, again in infrared, sensing heat. Highlighted here in yellow, over 1 million square miles of ocean reaches a critical temperature, 80 degrees. At this temperature, the sea is evaporating fast, producing an invisible gas, water vapor.
By looking at the infrared, the Aqua satellite is able to measure the amount of water vapor evaporating from the surface of the ocean.
Aqua shows that this area is producing millions of tons of water vapor every hour. Based on that data, it's possible to create an image of what the vapor might look like if these fishermen could actually see it in the air around them. Water vapor is much lighter than air, and vast columns rise upward directly from the surface of the sea. The water vapor carries with it heat, the energy of the sun.
Well, water vapor is like invisible energy. It's like molecules escaping the ocean, taking heat energy with them, and they're like little mobile solar collectors that are zipping around the atmosphere.
Half a mile up, as the air cools, the water vapor condenses back into liquid water, tiny droplets that form vast clouds. The vapor releases the sun's energy, the heat it received earlier. The result is a storm.
Molecules condense in the atmosphere and become liquid again, and when that happens, that heat is given off into the atmosphere and it warms the atmosphere, and that's the heat that powers storm systems.
In the worst storms, the heat captured by the water vapor is equivalent to up to 200 times the global production of electricity at any given moment. The process of evaporation results in something we don't need special instruments to see. The rising heat drives the clouds up to 10 miles high. As the clouds rise upward, the Earth's rotation causes them to spin. The thunderclouds merge into a vast vortex. This is the birth of a hurricane.